All right, so let's begin. So we're going to start with finding an equation of a line. So I really want you to know this equation, this y minus y1 equals mx minus x1. So this uses a point and a slope. So that's going to be the situation we'll be in many times through this semester. Mx plus b, that's usually a nice way that a textbook likes to write it in the back. I'm not going to be concerned about that. And there's not very often we're going to get the y-intercept to help us. So let's go to it. So here I have a point, and I need to find the slope from here because I'm going to find the perpendicular slope. So you know to find the slope. Let's rewrite it. So I get to here. So the slope of this line is -1/2. So the perpendicular, and you probably know that's a symbol for perpendicular, so the perpendicular slope will be 2. So I'm going to put together the equation of the line. Y minus 2 is equal to the slope 2 times x minus 6. And that's a fine answer. All right, so here I've got an x-intercept and a y-intercept. So I'm going to make the points that these are coming from. So the x-intercept means the x is 2 and the y is 0. And the y-intercept means is the x is 0 and the y is -7. So from these 2 points, I can find the slope. So I have -7 minus 0 over 0 minus a -2. So I have a slope of 7/2. So using this slope of 7/2, I can use either point. Doesn't matter. So let's use this one. So I get y is equal to 7/2 times x minus 2. And again, you could multiply that out, but that's a fine answer. All right, so let's move on to completing the square. That is going to be something we'll be needing to use all year long. And so let's go at it with looking for the center and radius of a circle. So completing the square on these two x terms, you've done this before, I know. You take half of this number, -8, and I'm going to square it. And by doing this, I'll get x squared minus 8x, but I'll also get a plus 16, so I have to add 16 to the other side. So completing the square on the y terms, take half of the 12, so I'll get 6, square it. I've added 36 to this side, so I'm going to add 36 to this side. So I get a 52 on this side. So I now know the center is 4, -6. And the radius is √52. And that's a fine way to leave your answer. All right, this is asking it a little bit different way. So if they're telling us this is the center, so not that we're going to draw it to solve it, but let's just get an idea of what's going on. So there's 5, -2. That's where the center is. And it passes through this point 7, 3. So 7, 3 is way over here. So this is the circle I'm looking at. So I can find, with knowing that this is the center, I have x minus 5 squared plus y plus 2 squared equal, so I need to find the radius, and the radius will be this distance between these 2 points. So how do I find the distance between these 2 points? Well, that's the distance formula, and here it is right here. So it's going to come up, you just need to know it. So the distance will be the radius. So let's just go find it. So that's going to be 7 subtract 5. So it's going to be a 2 squared plus 3 subtract a -2. So that'll be 5 squared. So I'll have 4 plus 25, or √29 as the radius. So then to put together the equation of the circle, it'll equal 29. All right, let's just finish this little section here of solving quadratics. You always want to get it equal to 0 and see if it'll factor. So let's look at this one. 3x squared minus 5x minus 2 equals 0. So equaling 0 always. And let's see if we can figure it out. So 3x and x, -2 plus 1, that works. So I get x is equal to -1/3, or x is equal to 2. Okay, so this looks relatively simple, but I want to make sure that you're never going to divide by x. Always get it equal to 0, so then you can factor out that common term, and then get x equals 0 and x equal 1/2. So let me just show you, if you had divided by x, which is wrong, if I had divided by x, I would have gotten 2x is equal to 1, and I would have gotten just the one answer of 1/2. I would have missed this answer. So when I say you're losing answers when you divide by variables, you lost the answer of 0. So don't divide by a variable or a cosine or a sine. Always get it equal to 0 and factor out. All right, so looking at this one, getting it equal to 0, it does not factor, so that's when you know your quadratic formula. So let's go use it. -1 plus or minus b squared minus 4ac all over 2a. So you see right in here we have root -3. So we do not use imaginary numbers in our calculus, so we say no solution at this point. This symbol, this 0 with a line through it, that's set notation. We're never going to use that. So if there's no answer, you say no solution. So never use that. All right, this definition here is really big. Sorry, that's my attempt at a star there. So what this says is, if the number x is bigger than 0, the absolute value definition says you take itself. If the number is smaller than 0, what we do is we take the opposite of that negative number. So here's an illustration. So the absolute value of -2 is the opposite of that negative number. That's how I get the number 2. Okay, so that's how the definition works. And this is going to come up, so just make sure you've got this, you know where this is. This is a fact that's going to come up. We're going to be using this algebraic square root of x squared is equal to the absolute value of x. Because if I take the square root of, say, -3 squared, that's the square root of 9, that's positive 3. So we always get the positive answer if the radical is written down. When is it that we get the plus minus? Let's kind of go off to the side here and just kind of talk about that. If I'm solving something like this and I go in and take the square root of both sides, that's when I get x is equal to plus or minus 3. If the radical is there, we take the principal root, and that's why it's always positive. Okay, so the absolute value also means distance from the origin. So I want you to know this and this. What the absolute value is less than a, and when it's greater than or equal to a. So let's talk about what those look like with numbers here. So if it says absolute value of x is less than or equal to 1, that means the distance from the origin is smaller than or equal to 1. So I'm just going to show it. It'll include this point all in here and include this point. Okay, so how we can write that in one math sentence is we can say between -1 and 1. So when it's a less than inequality, it turns into one sentence. If it's not a less than inequality, if it's greater than, then what that means is the distance from the origin is bigger than 2. So that means out this direction and out this direction. And I've just randomly made this an equal and less than or equal and this just a greater than, so you see the difference of when you include the endpoints and when you do not. Okay, so I have to say this, x's are smaller than -2 or x's are bigger than 2. So there's two separate answers for this. Cannot be written as one statement. All right, so let's go through and solve these. So this statement here, 5x minus 2, the distance from the origin is smaller than 1. So I'm going to put it between 1 and -1. Now I'm going to add 2 everywhere. So I get this, and then I'm going to divide through by 5. So this is the solution. X is between these two numbers solves this. So this has a greater than. So I'm going to have 3 minus 2x is bigger than or equal to 4, or 3 minus 2x is smaller than or equal to -4. So again, I'm going to solve for the x. So I'm going to subtract 3 from both sides. And then I'm going to divide through by a -2, so you know that changes the sign. Do the same thing here. Subtract 3. And then divide through by -2, so that changes the sign. And so this is my solution.